Hello guys, today we are going to show you the basic connection of our latest development of HHO generator HS2000 Nano. This is Nano Generator, which means we applied nano coating over the plates. So this is the generator basically, and we pre-installed this reservoir, which is in the kit as well, and as well we put another two big bubblers which are not included in the kits usually. This is our test bench device actually, and here is our debit meter, so we can measure the debit of gas as well. And yeah, so now we proceed to put the hose, and for this reason, now that you will be able to see how the system is working, we will use transparent hose actually. Basically we do not use transparent hose in real installations, but for educational purposes I think it would be good to be transparent, so you will be able to see how the electrolyte is circulating between the reservoir and the generator. So now we proceed to install the hose between the reservoir, and can you start with the first line, which is filling up the system actually. So here on the bottom line, which is supposed to be connected from the bottom of the reservoir, where is the lowest point of the reservoir, and the electrolyte will be going down there to the generator, to this connector, only by the gravity way. So it's very important that the reservoir will be above the generator in real installations in vehicles. This is very important because we do not use pumps, we don't need them actually. So water, it's always liquid, it's always heavier than air, and it will be filling up the generator by itself, only by the gravity way. So it's very important to cut the hose exactly like that. So now we will fit a three-way connector here. So we will have also a draining valve in the system. It will be much easier for us to drain the system after that. It's very important to plug it to the maximum until you feel that it slides inside the push-in fitting. Very important thing. This is our draining valve, which should be on the lowest possible point in the installation on this line. So this is the lowest point of the installation. We're just connecting a small piece of pipe here, so you can see what I mean. When we need to drain it, we just have to release this valve, and it will drain the system from here, the whole amount of electrolyte. So now we are connecting from the bottom connector of the reservoir down there to this connector. Measure it twice, cut once, and then it's short as usual. Plug it well. Okay, good. So now we have to connect the higher connector push-in fitting on the generator up there, on the side mounted push-in fitting on the reservoir. This will be returning the produced gas from the generator. Upper point of the generator will be going to the reservoir, so it will be moving the produced gas from the generator to the reservoir. Okay, plug it well. Isn't it cut well? It's not. Okay, you can recut it. Good. So now when we fill electrolyte, it will go down this way, down there, to filling up the generator with electrolyte, and this electrolyte will come back here, and later on when we start the system you will see you will be able to see, because we use now this transparent hose, how it's going the produced gas back to the reservoir, and it's separating from the whole amount of electrolyte here. And from the top pushing fitting, it will be going to the bubblers. We use these bubblers, double of these bubblers, so we will be able to see stable amount of gas per minute, because we need to measure it. That's why we use two bubblers in this case, otherwise it's bubbling with two big bubbles, and it's fluctuating a lot on the debit meter. So it's connected like this basically. So here only gas will be going to the bubblers, through this bubbler, and it will be going to the debit meter, which is not working at the moment. It's showing 0 debit per minute. It's showing actually normal liters per minute. I spent about 1,500 euro about this debit meter, calibrated, certified, and it's designed for HHO, as you can see on the display. I bought it from some German company. So we rely on this debit meter that is showing accurate results. This is very important thing, because I see many people are measuring by the ancient method with bottles and stuff like that and water, which is fine. Maybe it's showing something, but I'm not sure that it's real. That's why I spent 1,500 euro for this device. Not for pure hydrogen, not for any other gases like air, nitrogen or whatever it is. So next thing is that we will have to, let's connect the wires first. So we will use a power supply, which we are connecting it to 220 volts at the moment, and it's releasing 12 to 14 volts to the generator. Because the generator is designed for light vehicles, which usually have 12 to 14.5 volts charging system. So we will simulate now the operation like it's on a vehicle. So this is the ground. Connecting the ground wire to the ground connectors on the generator. And this is the positive connector on the generator. Okay, tie them up a bit. Okay, so now we connected the device to this power supply. Now we will have to fill electrolyte in here. Electrolyte is with 10% density, which means it's 100 grams of potassium hydroxide mixed in 1 liter of water. So we will fill it out now. As you can see, electrolyte is going into the generator, or maybe you cannot see it at the moment, but you will see the returning line now that is coming back when it's filled totally with electrolyte. Here it is. So now it's totally filled. In both of these hoses I see electrolyte, which is also transparent. It's a watercolor based, so I hope you will see the level as well. It's before the maximum. Actually we leave them in the middle between minimum and maximum here. See, there is a small minimum and here is a maximum line, so it's enough electrolyte. And now I can release some power from the power supply. So I will release first some voltage. Amps are to the maximum, so I have to release at least more than 8, 9, 10 volts to start the amps. Okay, we have 2.3.4 amps. .6 amps at 10 volts, and now the produced gas is coming back to the reservoir. We have 8 amps. Let's make it exactly 12 volts. At 12 volts exactly we have 9.3 amps approximately. I hope you can see it on the volt and amp meter which are integrated in the power supply. And you can see also here how the gas is coming back to the reservoir. At the same time, all the time actually, electrolyte is filling up the generator, the nano generator, and is going back to the reservoir. So it's circulating all the time this way until the water is used already to the minimum, and it will stop. Usually in real installation we have a floating switch here, so when it gets to too low level it will shut off the system automatically. And as you can see now, the bubblers also are bubbling. So let's make more amps. Now we have 10 amps. At 12.3 volts. So this is the oxyhydrogen gas we produce for the moment. It's not that much as a debit. Okay, it will be heating up a little because electrolyte is not hot yet. So here we have 20 amps at 14.5 volts, 21 amps. And here is the debit per minute, 2.2 liters, 2.3 liters per minute, 2.4 liters, 2.5, 6, let's see, 2.8. It should be working for a while to heat up a little. The electrolyte itself, I mean, in the reservoir and in the system. So when the electrolyte gets hotter, actually it has more conductivity, and in this case it's producing more and more gas, of course. Okay, now we have 3.9 liters, 3.8, 9, 4 liters per minute at 20 amps and 14 volts. Let's see. 14.1, 20.5 amps. So again, this is what we produce per minute. 4.8, 5 liters per minute. So this is the efficiency of nano generators. It's not producing at 20 amps and 14.1 volts 1 liter or 1.5. It's producing over 5 liters, as you can see. Very, very important thing in a matter of efficiency. It's not about just to make something to bubble, but to measure it properly with precise and accurate devices like this one, which I bought it from Germany. I will say again that I spent 1,500 euro for this device to be able to measure it absolutely precise as a debit per minute. Six liters we saw just quite a lot. I hope that there will be some comments below this video. Please comment, ask questions if you want. I'm showing this, and I bought all of these devices, this especially, just to be able to make sure what I'm producing as a gas per minute as a debit. Very important thing. 6.3. 6.3 liters, and this is at 22 amps, 14.1 volts. So this is quite a debit that it will be working on vehicles with engine displacement between 1 and 2.5 liters. So we designed this device to be working on such engine displacements between 1 and 2.5 liter, and that's why we needed to improve this technology. 6.5 liters per minute of HHO. So that should be enough for a vehicle up to 2.5, maybe up to 3 liter even. Of course, we will show you in video a real installation in a vehicle, so you will be able to see how we do every step of the installation. Very important thing, because it's not something that you can easily just open it from the box and plug it somewhere. It's hydrogen systems, they need to be installed and mounted very well and properly in the vehicle. The proper connections of holding this element, the generator, the reservoir and the bubbler which is included in the kit, they should be installed very well to the chassis of the vehicle, possibly near the engine, or in other case you can install it in the trunk as well. But in any way, we provide all of the items that you will need for the installation, for the wiring, and for proper setup of the system in the vehicle. So you will be able to do it easily this way. As most important thing is to find a space for this for these items, for the generator and for the reservoir and for the bubbler. The rest it's easy because it's only hoses and wires, and the Dynamic PWM is quite small. I will show you. So this is usually the control device of the system when it's installed in a vehicle. So it's taking signals from the battery from other places. I will explain on another video how it's working exactly, this Dynamic PWM. As you can see, it's very compact, so it doesn't take that much space. It doesn't need cooling as well, so that's why it's in this small box, this small enclosure. And that is it. Let's see again how much gas we produce. 6.8 liters per minute. So if you're willing to measure your efficiency, if you already proceed to do something yourself, as a generator, as a reservoir, a system, HHO system, you can always use our efficiency calculator on our website, hydroxsystems.com. So there is efficiency calculator when you apply correct details about the energy you use, I mean the voltage and amps, and if you have proper precise measurement of the gas, you will see efficiency calculated automatically, so you don't have to calculate it yourself to waste your time. I mean 6.9 liters per minute, almost 7 liters per minute, with 12 volt system, designed for light vehicles, cars, vans, any kind of equipment that you can use this gas, just to enrich the air fuel mixture. And when you enrich the air fuel mixture of air and diesel, or air and petrol, CNG, LPG, doesn't matter what kind of fuel you mainly use in your vehicle, when you enrich it with oxyhydrogen gas, it will increase the burning efficiency of the other fossil fuel, and the thermal efficiency it will increase. So based on this, you will get lower fuel consumption and much lower emissions. So lower emissions also prevents carbon build-up in your engine, like air intakes, EGR valve, swirl flaps in the air intakes, sprayers on the diesel nozzles, on the injectors, especially on direct injection engines, as well carbon build-up over turbo and its variable geometry, as well catalytic converter and diesel particulate filter. Most of these elements, they're suffering of carbon buildup. So if you install such system, you have to forget about carbon buildup and its related problems. So there will be no any more problem with the carbon buildup in the engine. And you will pass probably any emission test, because there will be so low emissions that you can pass any emission test and annual checkup or anything like that. Okay, we have 7 liters per minute. So I will show in another video as well how we calculate the efficiency, so you will be getting much easier as information how you can calculate it for yourself as well. If you are experiencing some issues with measurements and stuff like that, we can help you out also. Just you have to leave an email to us and we will reply to you. Okay, so you saw the basic installation on a test bench, how we do it. This usually is supposed to be installed in a vehicle, just on a lower level than the reservoir, and then there is a smaller bubbler in the car installation. In the kit we provide actually this bubbler, because it's much compact than these two. These two we use just for testing purposes here, so they are mounted on this wall as well with the debit meter. And that is it for the moment. So if you have some more questions, please leave an email to us, and or you can write below this video. If you like this video, just hit the button like and follow us for more interesting information. Thank you.